Good morning. I am Dr. Pradeep MN, professor from Department of Biomedical Engineering. Today I will be discussing with you how to convert delta to star conversion. Okay, so let us see what is the use of conversion from delta to star or star to delta. See, to solve complex circuits, we need this, and to solve for 3D electrical circuits and to solve for bridge circuits, etc., we have to use conversion from delta to star. By using simply a series or parallel circuits to find the effective resistance, it's not enough. For the complex circuits, we need delta to star and star to delta conversion. That is why I have taken this topic. See, conversion from delta to star. What we have to do here, see, in delta circuit we have got 3 resistors, as well as in star circuit we have got 3 resistors. What we are going to do here is we have to find the effective resistance across the terminals. So the delta terminal across AC will be equal to the star terminal across AC. That is what I have written here. Delta terminal effective resistance RAB is equal to the effective resistance across star RAB. Similarly, delta RBC will be equal to star RBC. The effective resistance across RBC in delta circuit is equal to the effective resistance across star RBC, and delta RAC, that is the effective resistance across RAC in delta circuit, is equal to the effective resistance across star RAC. That is what I have shown here. I have taken these equations as Roman number 1 equation. On solving, I make you easy. I give you a tip how to solve for this. So what we do here, we try to open the terminal at terminal A, terminal B and terminal C at a time 1. Okay. So initially if I open the terminal A, on opening the terminal A, what will happen? So what we get? So we can replace the effective resistance RA. Okay, RA can be calculated as RA is equal to, we have to multiply the opposite terminals of delta. So to find RA, we have to multiply RAB of delta with RAC, and we have to divide the entire thing by the summation of all the elements given here. That is RAB plus RBC plus RAC. Okay, so on opening terminal A, we are going to solve for RA. So on opening terminal A across both delta as well as star, we can solve for the star element RA. Okay, and similarly on opening terminal B, we can solve for RB here. So if you open the terminal B here, okay, for both delta as well as star, we can find the effective resistance RB. Okay, so RB is given as I said you, we have to multiply the opposite elements of delta. To find the star RB, we have to multiply the opposite elements of the delta. So RB will be equal to RAB into RBC upon total summation of the delta elements. That is what I have shown here. On opening terminal B, RB, that is star RB is equal to RAB into RBC of delta divided by summation of all the elements of delta elements. Okay, and similarly on opening terminal C, okay, we can find the element RC of the star element. So RC will be equal to opposite terminals multiplied, we have to multiply the opposite terminals of delta, that is RC is equal to RBC into RAC, okay, divided by summation of all the elements of the delta. Let us see, this is the simple format I have shown you to make you easy. So how to solve for this? As I said you, we are going to open the terminal at one at a time. Okay, I have done here. So I have opened the terminal A. So what happens on opening the terminal A of both delta as well as star? See, I have opened the terminal of delta here. So what will happen by opening the terminal A here? The current will not pass here. So whatever current flows in RAB will flow through RAC. Hence we can say RAB comes in series with RAC, and these two elements comes in parallel with RBC. So I can solve for delta RBC. So if I open the terminal A here, I will be solving for the effective resistance across BC. Okay, so delta RBC will be equal to RBC, as we know that R1 into R2, parallel element, R1 into R2 divided by R1 plus R2. I consider this one as R1 and these elements as R2. Okay, on doing that, we can solve for delta RBC. So delta RBC will be equal to RBC multiplied by the summation of RAB plus RAC upon sum of all, because it is R1 plus R2. As I said, I considered this one as R1 and these two elements as R2. So as resubstituting, I will get the delta RBC here. Okay, on solving this, I get delta RBC is equal to RAB into RBC plus RBC into RAC upon summation of all the three elements. So we know that by condition 1, that is Roman number 1, listed in the previous equation, as you know here, it has been listed here. Okay, delta RBC is equal to star RBC. So I will take this into consideration and I will solve this. So that is what shown here. So delta RBC on solving the star element by opening the terminal A, on solving the star element, see, there is no current through RA here. Whenever there is no current through this particular element, that element becomes redundant. Okay, and we should not consider RA here. And whatever current flows in terminal B will be flowing through terminal C. So it's the same. If the same current flows through both the elements, then we can say those elements are in series connection. Therefore, I can write the effective resistance across star RBC is equal to RB plus RC. Okay. Now I implement equation Roman number 1. So equation Roman number 1 tells that delta RBC is equal to star RBC. So, or we can say vice versa. I take the star RBC first here. So star RBC is equal to delta RBC. So we know that star RBC is nothing but RB plus RC and delta RBC is the given equation here. Okay, I call this equation A. So this is done by opening terminal A and I call this equation as A. And similarly on opening terminal B, see that I have shown here the figure, I have opened the terminal B here. So whatever current flows in RBC will be flowing through RAB. Hence these two elements comes in series and these two comes in parallel with RAC. And here we are going to find the effective resistance across terminals RAC. Okay. So for delta RAC, which is equal to star RAC. And in star RAC, what happens if I open the terminal B? There will be no current through RB and hence this terminal becomes redundant. Whatever current flows in A will be flowing through C. And I can say these two elements comes in series. Okay, and the delta star RAC will be combination of RA plus RC. And rewriting from equation Roman number 1, we know that delta RAC is equal to star RAC. So on rewriting that, RA plus RC of star is equal to, okay, delta element combination RAB RAC plus RBC RAC upon summation of all the three elements. So I call this as equation number B. Similarly, on opening terminal C, what happens? See here. On opening terminal C, I have opened the terminal C here. So on opening terminal C, we will find the effective resistance across terminals A and B. So delta RAB. Okay. So delta RAB I have solved for that. So delta RAB will be this equation. Okay. And similarly for star RAB, if I open the terminal C, there will be no current through RC and hence RC will be redundant. These two elements comes in series. Therefore, star RAB will be equal to RA plus RB. By using Roman number equation 1, okay, we can solve for this. So that will be RA plus RB is equal to RAB RBC plus RAB RAC upon summation of all the delta elements. So we got equation A, we got equation B and we got equation C by opening the terminals A, B and C. And solving for A, B and C, we can easily identify the star RA, star RB and star RC. Let us see how it is solved. So to find star RA, this is the method I have followed. So you too can follow this method. So to find the star RA, I said I have opened terminal A to solve for RA. So what I do, I call that equation as A. So this is the method. To solve for RA, it will be negative A. To solve for RB, it will be negative B. I have done it. I'll show you in the next slide. So here, minus A means we can solve for RA. So what I do, I have substituted equation B, equation C, and equation A. Equation A, I have calculated for both RHS as well as LHS. I solved for both. On solving RHS and LHS, this is what I got. So from RHS, I substituted equation B RHS, I substituted equation C RHS, and minus of equation A RHS, which is equal to equation B LHS, equation C LHS, and equation A LHS. Okay. And finally solving this, these terms gets cancelled out. Okay. And finally I get 2RA is equal to 2RAB 2RAC upon RAB plus RBC plus RAC. We can cancel out two term here. And finally RA will be equal to RAB RAC upon summation of RAB. That is what I said earlier. Okay. So this is a star RA. For star RA, we have to multiply the opposite terminals of delta. That is what we have done here. And finally, summating all the three terminals of delta. Similarly, to find star RB, okay. So here I have done for equation B. So I have subtracted by equation B for that. So equation A minus equation B plus C. This will help to solve star RB. So on substituting the values for A, B and C and solving it, we are going to get RB is equal to RAB into RBC. That is the opposite components. As we can see here, RB is the element here. It is a multiplication of opposite values. Okay. And finally summation of all the values. So it is given as equation 2 here. And similarly to solve for the element RC of star, okay, I have taken as equation A plus equation B minus equation C. On solving this, I get RC. As I said you guys, RC will be equal to, we have to multiply the opposite terminals of delta. So RC will be equal to RAC multiplied by RBC, okay, divided by summation of all the elements of delta. Okay. By doing this, we can solve, I have called these equations as 1, 2 and 3. On solving equation 1, 2 and 3, we can convert from star to delta conversion again. Okay. Yeah, I will continue in the next lecture series on that. Yeah. Thank you.